well, yes, welcome to CBE 5 review. I'm Megan, and this is Kaylee. We've been having trouble changing the slides. Oh, there we go. So, yes, here are the topics we're going to cover. There's square roots to solve an equation, and then quadratic formula and solving linear inequalities, and solving the inequalities with absolute value, and functions and two variable equations and graphs. So yeah, we'll see examples of those. So when it says extracting square roots, that just means you'll have like, here's an example. You might have something like this, so then you can like take the square root of both sides. And then, yeah, so like that's what we're talking about. So the one important thing with these is you want to make sure to have plus and minus. So the reason for that is, like in this example, square root of 9, it could be 3, because 3 times 3 equals 9. But it could also be negative 3, because negative 3 times negative 3 equals 9. So we want to account for both possible solutions. Okay, so here's an example of this. So we have 5x minus 3 squared equals 81. So we can take the square root of both sides. The square root of something squared just gets rid of those. And we have 5x minus 3 equals plus and minus square root of 81. So we'll do positive 9 over here and negative 9 over here. So we can add 3 to both sides. My handwriting is bad. 5x equals 12, then divide both by 5. We get x equals 12 fifths. So that's one answer. And over here, we'll get our other one. So add 3. 5x equals negative 6. Divide 5. X equals negative 6 fifths. So there are two answers.
All right, did you feel good about that one? Okay, perfect. So we'll move on to the quadratic formula. It's probably going to give it to us. Yep. So this can be used to solve any quadratic equation, just like it says here, as long as it's in the form ax squared plus bx plus c equals 0, right? So the equation is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so we'll see an example of that. So first, we're going to determine the real number solutions to this equation. First, it has to be equal to 0 in order for the quadratic formula to work. So we're going to subtract. So I'm just going to rewrite this over here. 2x squared minus 1 equals 2x. We're going to subtract this 2x. So we're going to subtract 2x from both sides. So we can set it equal to 0. We'll get 2x squared minus 2x minus 1 equals 0. And now this is in a form that we can use the quadratic formula. This is going to be our A, this is going to be our B, and this is going to be our C. So I'm just going to rewrite the formula, negative B plus or minus square root of B squared minus 4AC over 2A, and we'll plug it in. So we've got negative, oh, I wrote that too high, ignore that. Negative B plus or minus square root of B squared minus 4AC over 2A. Okay, do you feel good about that so far? Perfect. Okay, so now I'm just going to simplify from this point. So, and I'm going to move it over to the left side because I didn't leave myself very much room. So we're going to move over here. So those negatives are going to cancel. We're going to be left with a 2 plus or minus the square root of 4 This -1 is going to make this a +4 over here. And then we'll have 8, so 4 plus 8 over 4, which is equal to 2 plus or minus the square root of 12 over 4. Okay, now we can simplify this a little farther because our 12, we can break it down into its factors. So 12 is going to break down into 2, 6, 2, and 3. We have a group of 2's right here. So we'll pull them out. So we get 2 plus or minus 2 square roots of 3 over 4. Do you still feel good about this? Perfect. Okay, and then the last thing we can do is divide everything by 2. This is equivalent to 1 plus or minus square root of 3 over 2, which means our two solutions, R1x is equal to 1 minus root 3 over 2 and 1 plus root 3 over 2. And then we'll double check our answer. Sweet, that's what they got as well. Do you have any questions on that example? Okay, awesome, we'll move on.
Okay, so this one, it's still quadratic because if we multiply this out, we get an x squared. But the problem is it doesn't equal 0. So the reason that's a problem, I used to just like try to solve it like x minus 3 equals 3, set each part equal to 3. But that doesn't work because what we're doing is we're using the 0 factor property. So if a something times something equals 0, either a can be 0, and I'll make it true, or b can be 0. But if we have like a times b equals 6, like a could be 1, b could be 6, a could be 2, b could be 3. So we can only set each piece individually to 0 if this like equals 0. We can't set it individually to a different number. So one thing we could do is we could multiply everything out and then try to get it to equal 0. So we can use this. So I'm gonna do the first times the inside will give us -3x, and then outside is plus 4x, so that gives us just plus 1x. -3 times 4 is minus 12 equals 3. And then we can move this 3 over to this left side. So, sorry, that'll be a -3 minus 15 equals 0. And then we could check if this factors, so we'd need something that multiplies to -15, adds to 1, and then -5 and 3, that doesn't work. I don't think there is anything, so we can just use the quadratic formula. So our b here is 1, a is also 1, and c is -15. So we have -1 plus or minus square root, 1 squared is just 1, minus 4 times 1 is still 4, times -15 over 2 times 1 is 2. Any questions so far? Okay, so then we can just simplify further. -1 plus or minus square root of -4 times -15 will give us a positive 60. So 1 plus 60 is 61 over 2. Then 61 can't break down into anything that we can pull out, so our answer will be -1 plus root 61 over 2 and -1 minus root 61 over 2. Oh, it says x equals. Okay, any questions on this one? Yep, we got it right.
All right. So this is the same kind of concept, except it looks a little bit worse at the beginning, right? Do you have any ideas of how we first approach it?
Do you get a common denominator?
Yes, that's exactly it. So we're gonna factor this guy to get a common denominator, because we can't really do anything from this point. So this is going to factor. We need something that adds to 4 and multiplies to 4, which is gonna be 2 and 2, right? Okay, so we will have x plus 2 and x plus 2 is what this factors to. So to get that common factor, now we just need to multiply this guy by x plus 2 over x plus 2. Do you feel good about that? Okay, so that's what I'm gonna do. I'm gonna go ahead and erase this so I have a little more room. Okay. So we've got 3, oh, I changed the color, x plus 2 over x plus 2, x plus 2 minus 1 over x plus 2, x plus 2 equals 2. Okay, now we're gonna multiply this through, and then we're gonna subtract that 1 from it. So we got 3x plus 6 minus 1. 6 minus 1 is gonna give us 5, so I'm just gonna put a 5 above this, over x plus 2 squared. And I'm just gonna put that so I don't have to write out the whole thing again. Is equal to 2. Now, this is something we can do a little bit more with, right? So we're gonna multiply both sides by x plus 2 squared, so we can get it out of that denominator, and then we can hopefully solve for x. Sorry. So, oh, I don't want the solution. We'll have 3x plus 5 is equal to 2, x plus 2, x plus 2. Okay. Now I'm gonna FOIL this. So we'll have 3 plus 5 is equal to 2. Onto the top first. X squared plus 2x. Then here, plus 2x plus 4. Just gonna simplify that. It's equal to 2 x squared plus 4x plus 4. Okay, now I'm gonna multiply the 2 through to all 3 of these terms. Can you still see okay? Okay. Okay, and then now what do we need to do from here to use the quadratic formula?
Set it equal to 0.
Exactly, set it equal to 0. So we're gonna move all the terms to one side. To me, it seems easier to get a 0 on this side, but you can do either side and it will still work either way. We're gonna do this side. So I'm gonna subtract 3x and I'm gonna subtract a 5 from both sides. That'll give us 0 equals 2x squared plus 8 minus 3 is gonna be 5x. And 8 minus 5 is gonna be 3. Okay, you feel good about that? Sweet. Now we're gonna use our quadratic formula. Here's a, b, c. So negative b plus or minus the square root of b squared minus 4ac over 2a. And then I'm just gonna simplify from here. So we got negative 5 plus or minus the square root. This is gonna end up being 25. And we're gonna subtract 4 times 2 gives us 8. 8 times 3 is going to be 24 over 4. And then that's gonna simplify to 1. That's awesome. Plus or minus square root of 1, which we know that's just 1. So I'm gonna just write 1 over 4. Okay, so now we can solve this a little farther because we don't have our square root anymore. I'm gonna do the minus 1 over here and the plus 1 over here, okay? So minus 5, negative 5 minus 1 over 4 equal to negative 4 over 4, which equals 1. And then on the plus 1, we got negative 5 plus 1 over 4 equals, oh, I did this one wrong. Oh my goodness. That should be -6. That's my bad. -5 minus 1 is -6. That's going to give us -2/3. This one will give us a -4. -4 over 4 equals 1. So our solutions are x equals 1 and x equals, oh, it's -1. Man, -1 and -2/3. Okay, do you have any questions on that? Other than my algebra going crazy? Okay. And then that is indeed what it is. Oh, 3/2. Man. That one really threw me. -3/2. So that's going to simplify too. -3/2. Okay, that should be it on that.
Okay, so inequalities are things that like, instead of an equal sign, it has something else. So we might have like 4 is less than 6. So this isn't an equal sign. Or we might have x is less than or equal to 10. But these we can solve almost the same way, except there's one important rule. When you multiply or divide by a negative, you have to switch the direction. So if we had like -x, I almost wrote equals, we'll do -5. So to do this, we would divide both by -1 or multiply. It doesn't matter with -1. So that's x and then 5, but we have to swap the direction of this. Okay, any questions on that?
So,
Okay, so here we'll do an example of this. So we have 3x minus 9 times 5x plus 4 is greater than or equal to -5. So first thing I'm going to do is I'm going to distribute this 9 to clean it up a little bit. We have 3x minus 45x minus 36 is greater than or equal to -5. So here I multiplied by a negative. Why did I not switch the sign? Oh, yes, do you have a question?
could you also, like, instead of multiplying the 9 through, could you just move it over? Or like move, wait, maybe not, never mind.
Okay, yeah, like you could do things in a different order, like if you wanted to move the 3x and then divide the whole other side by 9, or divide everything by 9, you could do that, if that's what you're meaning. Yeah, so then in this case, when I multiplied by a negative, the reason I didn't switch the sign is I was just distributing now. I didn't like multiply everything by a negative to switch everything. So that's why I didn't switch in this case. And then, so 3x, I'm just going to combine like terms. 3x minus 45x is -42x minus 36 is greater than or equal to -5. So combine all the like terms. What can I do now?
Can you set these to 0 or?
Yeah, you could do that. Should we do that?
Sure.
Sure. Okay, we can move this 5 over here. So then we have -42x minus 31. So now our goal is to get this x by itself. So there's kind of two things attached. We have this -31 and this -42, right? So how can we get rid of this -31?
We add it to the other side?
Yeah, so we can do -42x. We add it to both sides, that gives us this. Then how can we get rid of this 42?
Divide it by the 30.
Mm-hmm. By -42. And I don't think that simplifies.
Yeah,
That's good. Yeah, so is there anything special about dividing by -42? Yeah, what do we need to do differently?
flip the sign.
Yeah, that's exactly right. So it'll just be this direction now. I think that's it. Oh, I think it's gonna have you put it in interval notation. Like sometimes on the CBE, it will say that. So interval notation is something that looks like, I don't know, you might have from like 4 to 6. So this, here, I'll draw a little picture so we can see what's going on. So x is less than or equal to this. So here's everything that's less than. And then right here, kind of depends on what teacher you have. Like Jenna, I know puts like this little bracket here to show it's included. Some teachers might do like a closed circle. It's the same thing. So that shows us it goes from negative infinity, because it just keeps going down, to negative 31 over 42. Now on this side, we're going to do a parenthesis, and this side a bracket. So the bracket is because it's included. Why is negative infinity not included? It's kind of a hard question.
I don't know.
Yeah, it's kind of weird, but negative infinity isn't actually a number. It's just kind of saying it goes down forever. So like it's not included because we can't like put negative infinity into this and make it work because it's not a number. So it's just saying it goes down forever. Perfect. Okay. Oh, I guess, are there any questions on this one?
All right, so now we're on to solving linear inequalities with absolute values, okay? So first you're gonna wanna isolate the absolute value by itself. So you have it on one side. I don't know what you have in here, so you have x plus 3 in here. You wanna get it all by itself on one side of the equation. Then you can set up two scenarios that are gonna account for the negative and positive possibilities. And the solutions for both of those are gonna account for it. So for this example here, what we're gonna do, since it's less than 1, that means that if we drop those absolute values, -1 is going to be less than or equal to x plus 3, less than or equal to 1. So those are equivalent expressions. You feel good about that? Okay, sweet. So we're gonna solve this inequality. 5x minus 2 in absolute values is less than or equal to 10. So this is the exact same as one we just saw. That means that this is between -10 and 10. As soon as we write it out in this form, we can drop those absolute values. So from here, it's kind of like solving an equality, but you have two sides to it. So we got to get rid of this 2 first. So what we're going to do is we're going to add a 2 to everything. You get -8 less than or equal to 5x less than or equal to 12. Now the only thing that's left is this 5 right here. We've got to divide everything by 5. So 5 by 5, 5 by 5, and we're going to be left with -8 is less than or equal to x less than or equal to, over 5, 12 over 5. And then if it wants it in interval notation, since we have less than or equal to signs, that indicates that we're going to use a bracket. So we have a bracket, -8 over 5 to 12 over 5. Okay, let's double check that. Awesome. Do you have any questions on that one?
If the inequality sign was the other way, would you have to use that like U thing in the middle?
The union? Yes, you would. And I think there's an example. Is that right?
Yeah, so if it was like less than, or I mean a greater than.
You're saying if it was like
You don't have 2 separate intervals with the union between them.
like that?
Uh-huh.
Yes, yeah.
Okay.
And there is an example of that next. Although if you have, like, I think that's a very next example. If you have any more questions about that after this, though, we can also do another example with it. That's a great question. Any other ones on how we did this one? Okay, So I'll let you take it from here.
Okay, so this one, you want this by itself. So how can we get that by itself?
Subtract the 3 over.
Yeah. So then we have, that gives us 0. So this is kind of an interesting case when we get 0 over here, because what will an absolute value spit out, like no matter what x is?
Positive.
Yeah, so it's going to be positive, or it could be 0 still if like we had -9 in here. So will a positive number or 0 be greater than 0?
Yes.
Yeah, it's always gonna, positives are always greater and 0 is always equal to 0. So in this case, it's just everything. So sometimes they'll write it like this for all real numbers, or I think this problem is just saying you'll have everything. Yeah, so yeah, I'll show an example of something that would use a union. So maybe if we had just an x in here greater than 5. So in this case, we'd have like x is greater than 5, and x is greater than, I need to flip that. Oh, I switched the color again. That's okay. -5. So then
Why
here,
would you flip it?
so this, I was just like separating this out into the 2 equations. So we flip it every time because we kind of change everything. So if, remember when we just had like an absolute value equals something, and we did the positive and the negative. So this, it's almost like you're multiplying everything by like -1. You're just flipping this and this. So yeah, we flipped the inequality and the thing on the other side of it. So this, we draw a little picture. 5 here, we'll do -5. So we have greater than 5, and then less than -5. And it can't be and here. This is, yeah, this is a greater than. So in this case, you do -infinity to -5, and then the union 5 to infinity. So this means or. So this or this, because it can't be this and this. Does that kind of answer your question?
Yeah.
Before? Okay. Any other questions on these? Perfect.
Awesome. So a function, it shows that every input has exactly one output, and it tells you how to get that output. So graphically, that means that this function passes the vertical line test. That just means, so if we had a graph, every value on x is going to map to a y. And there's, so if you had something like this, that wouldn't pass the vertical line test, right? Because right here, you've got 2 points at the same x value. So each x has its own y associated with it. Does that make sense?
Yeah.
Okay, I'm gonna erase that because that's not a function. That's defined here. Okay. And then f of x is a way of writing the output of a function when the input is x. So that's the notation we use. So usually we'll see like y equals like something like 3x plus 4, but it is the same to just say f of x equals 3x plus 4, or not the same, but it just shows, then we can specify the x we're plugging in. So I could give you something like f of 2, and you would know that you're supposed to plug a 2 in for this x here. Okay. And then the domain of a function is all of the x inputs that have an output. And the range is going to be all the possible outputs that it gives. And we'll go over those in a couple of examples. Okay, so if f of x is equal to this function, then find f of 3. So we kind of already talked about this. Whatever's in here is simply just what we're gonna plug in for each x value in our function. So I like to start with parentheses around it. I'll put parentheses around the 3 and then whatever happens to the x outside of it. So we've got 3 squared, 2 plus 4, and then we have another x right here, so I'll throw in a 3. Now we can just solve it. 9 over 2 plus 12, which is equal to 9 over 14. And let's check that answer. Sweet. Any questions on that one?
Okay, so this one, it's the same idea, it's just a little different because we don't have a number here. But we do it the same way, we just put x plus h in every place that we have an x. So out of x plus h equals x plus h squared. And it's for ones like this that the parentheses come in handy because we want this whole thing to be squared. 4 times x plus h. Now we could just leave it like this, or we could like multiply things out, because sometimes it will simplify. So then we get x squared plus 2xh plus h squared. That's just what happens if you square this. And then 2 plus 4x, I'm just going to distribute this, plus 4h. Now, I don't see anything that can simplify here, so this will just be our end answer. Any questions on this one? Cool. Yeah, so sometimes it will simplify, but yeah, this one it doesn't.
Okay, so now here's a domain and range problem. So we talked about the domain already. The domain is all the possible x values that give an output. So here, I'm just gonna represent this with a D that just means domain. We're gonna write it here. So that's all the possible x values here. So we're really just looking at like the x's right now. Does that make sense? So because this line goes off this way, we know that negative, like there's gonna be negative infinity on that side for the domain. So we'll have negative infinity. We use this parenthesis because of the reason Megan explained that it's negative infinity isn't a number. And then it doesn't break all the way up until this value here. And then we don't have any more x inputs after that. So this x value is 6, so we'll plug it in here. And then do you think it's going to be a closed bracket or a parenthesis?
Close.
Exactly, yep. And do you know why? That's okay. So it's just because it actually touches this point right here. This is filled in. If you had a point like this, if it said this at the very end, it wouldn't be touching that point. And that's the case where you would just use a parenthesis. But here, since it's actually touching the point, we are going to keep it inside of our domain. Okay, so the next part we're going to look at, and actually let me erase all this while we look at the range, is the range. This is the possible y values. I'm going to put an R for range. Oh, when I switch the color again. So again, let's look at like the minimum values first. The lowest it goes is this line right here, right? The y value on that is -1. And is -1 included?
Yes.
Yes, it is. So we will use a bracket on this one, -1. And then this line is going upwards towards infinity. It's never going to stop. So we'll just put, I was about to put negative infinity, but it's just going to be infinity on that side because it goes up and up. Okay, do you have any questions on that one? Okay, let's double check ourselves. Negative, sweet, sweet.
Okay. Now, so this one, we're just kind of practicing how to use a graph. So if we have a point like this 3, 7, do you know which one's the x and which is the y?
Yes.
Yeah.
Horizontal is x, vertical is y.
Yeah, perfect. So our x will be this and our y will be this. So our points are given like x, y. So this first one, we have 3. So we'll go 2, 3, and then up 7. 1, 2, 3, 4, 5, 6, 7. We'll get it right there. Now this next one, 2, 4. we'll go right 2, up 4. 1, 5, right 1, up 5. Now, here's one that's different because we have a negative. So the x is still positive, so we still go right 4. But then because we have a negative y, we go down 2. Then this one, we have a negative in the x, so we go left 6, and then up 0. So we just stay where we're at. Okay. Any questions on how the graph works?
I don't think so.
Cool. Perfect. So yeah, if you still want more help on your CBE 5, there's lots of places you could go. If you go to this website, usu.edu/math/AMLC, that it has like a lot of videos, like the recording of this will be posted, or yeah, other videos that can help you out. And there's also the tutoring center, which is just right over there. You can stop by anytime it's open, and you can also contact your recitation leader or your professor